How are you doing tonight?
I'm doing fine.
It's a cold night. Glad all my tutoring is inside. It's all online tonight. I don't have to go out in this weather. So what do we got tonight?
We had math testing today, but we also got our quizzes back, and I just wanna, because we have our unit test soon, I just wanna go over the problems I missed on the quiz.
Okay, can you verbalize them?
I can actually, two of them, the only two that, or two of them I can't verbalize, but I can take a picture.
Okay. Go ahead and take a picture of it and send it to me.
Mm-hmm.
And while we're waiting for me to get that picture, why don't you start with one that you can verbalize?
Well, there's only one more, and that's solve the system of linear equations by graphing. And actually, never mind. Sorry, that was the wrong thing. It was a word problem, and I had to write an equation for they had
Word problems are probably best to send me a picture of those two.
yeah.
There's so much information in them that by the time you get to the last sentence, I've forgotten what was in the first sentence. So it helps if I have a picture of that also.
Okay.
Let me know when you've sent it.
I'm sending it right now. There. And there's send another one of the one I have of the other one.
There it is. This looks familiar. We didn't do this one before?
No, I forgot that it was, I couldn't really tell that it was a dotted line because it was kind of dark in our classroom. And
Right. The dotted line is the hard one. If it's on that point right there, well, let's just look at each point.
I just missed 9 and 12
because
they were on the line.
Okay. So 0, 5. That's on the dotted line. Is that inside the shaded region?
Yeah, but no, actually.
No, it's not. When it's on the dotted line, it's not. If it's right there, it's not.
Mm-hmm.
That's 3 comma minus 1. That's the vertex of the shaded region, but part of that vertex is a dotted line. So you can be on the dotted line. But if I'm on the solid line, that is part of the region. Okay, so 0 comma minus 1 would be in the region. Minus 5 minus 1 is in the region. But anything on the dotted line is not. Got to be left of the dotted line. Now, write a system of...
Write a system of inequalities.
All right.
Represented by a graph.
Okay. So basically we have to figure out this graph. Hold on a minute. So we've got basically two lines that form this shaded region. What's the easy one?
Y is greater than or equal to -1.
The other one isn't really hard. It's a straight line. We just need to figure out what it's going to be in y equal mx plus b format. So if we put it into y equal mx plus b, what would it be?
Y equals -2x plus 5.
And now convert that to the inequality.
And if you test it,
Is it less
then
than or greater than?
it's greater than.
Look at the y. Always look to the y-axis.
It's greater than though.
Less than.
Oh, sorry, I was reading the wrong thing.
Pick a point on the y-axis. Make sure you go below.
Yeah.
That's less than.
Uh-huh.
Okay? And never say left or right. Always say above or below. Because we're always looking at y on the left side of this inequality. And when it's y, it's the y-axis you want to look to.
Uh-huh.
In other words, I have to find a point that is less than that line, and that means on the y-axis, not on the x-axis, but on the y-axis. The only time you would ever say right or left is if I had this. If I had x is greater than 2, well, that's a vertical line. We're right of that line, not left. Okay?
Uh-huh.
But whenever there's a y in the equation or inequality, then you're always going to be saying above or below. And that's important because a lot of people will be confused by this. This region right there. That above or below the line?
Below. Below.
It also looks like it's to the right of the line. And most people would say it's to the right, but don't use that terminology when you're dealing with an equation or an inequality that's got y in it. It's this side because I found a point on the y-axis that was below that line, and that's what makes everything be shaded there. Okay? So anyway, the system of equations you came up with works. That's what defines that region. Oops. Make this mistake all the time. So it was y is greater than or equal to -1, and y is less than -2x plus 5. So those are the two inequalities that define that graph. What else you got tonight?
I sent you the other picture.
Okay.
The one I got wrong was, so I got all the equations right, except for, and at least 4 pass plays, last line.
Okay. What's the first step on all word problems?
Define the variables.
Okay. So what are the variables? X is the number of
Run plays.
That's the number of run plays. The reason I put number is because that could be total yards of the running plays.
Yeah.
So it's important to be very specific when you're defining your variable. These are pass plays?
Yeah.
Okay, so write a system of linear inequalities. They had under 15 total plays. So what does that come out to be?
It is going to be x plus y is less than 15.
And then they had more than 6 run plays and at least 4 pass plays.
I got, for the 6 one, it's x is greater than 6, but it was the 4 one I got wrong. I said y is less than or equal to 4.
They did at least 4 pass plays. Got to be greater than or equal to 4. Doesn't that what that means? In other words, they could have done 5 pass plays or 6 pass plays, but they definitely did not do 3 pass plays. free pass plays would not be at least 4. So at least is what determines the direction of your inequality. So those are correct. And that's all we have, isn't it?
And then I had to... One second.
The rest of the equation I can't read. Not on my picture.
Write a system of linear inequalities that represents the number of plays. Yes. I have a tutor bulletin. It's write a system of linear inequalities that represents the number of plays the Chargers' offense could have had during the game.
Okay, so we've done that. And now what would be our what's B say?
Graph the system.
Okay, and in graphing the system, we'll figure out what combinations are going to work. Well,
you want me to...
No, I can do it on this right here. There's the x is 6, and we know that's the region for that. We know that y is greater than or equal to 4. Greater than, so it's that. And we know, how would I graph that? The x plus 1 is less than 15.
You go up to 15, then you draw a dotted line from 15 on the y to the x.
So basically what I'm going to do is put this into mx plus b format, right?
Yeah.
That's what it looks like. Now I can graph that by doing what you suggested, starting at 15 and having a negative slope of -1. Now, if I do that, let's see, this line is 4, so 15 would be up here. I'll do 15 in green. So I'm going to start about there. I'm going to have a negative slope of 1. And it's
and it would be below
5 less than. Right?
So the shaded area.
So everything that's got
the answer would be in the triangle.
Green, blue, and red in it is our answer. In other words, if I outline the area, so any combination of passing plays and running plays that fall inside this area are a possibility for what they could have. But it has to fall in that area. In other words,
it could be,
y could probably be 5, and x would be 7. If I figure out where 5, 7 is, let's see, this number is 6, so 7 would be right there. And if this number is 4, 5 is going to be right there. So if I plot that point, I'm inside that area. So I could definitely have 5 passing plays and 7 running plays. Can I have, well, I don't know. What does question B say?
Just graph the system.
Okay, so we did that.
But I got it docked.
Once you graph the system, that tells you all of the possible combinations. You know that first problem we had on the previous page where it gave you 5 points and it said which of these points are inside the region?
Yeah.
Well, that's a similar process we're going to do here. In other words, could x be 7 and y be 5? And the answer is yes. That point is inside the region. The other thing here that I didn't do is this green line is a dotted line.
Yeah.
And that matters, actually. Because
it matters because it determines where...
Yeah, that if
basically determines...
If a data point ends up on the green line, it's not inside the region.
And also when you find out that region...
Oh, and this one is also dotted. That's also dotted.
Yeah.
The vertical line. Yeah, the only one that's solid is the blue horizontal line, which I made dotted.
Yeah.
So that's solid. So if we're looking for points that are inside, they have to either be on the solid, they cannot be touching the dotted line
Yeah.
at any point. In other words, if I said, is that point in the region, yes or no?
Nope.
How about this point over here?
Nope.
How about this point up here?
No.
How about this point right there?
Yes.
On the line, yes. Good. Is that it?
Yeah. I only, got down 3.5 points.
Okay. So the only thing you really did was kind of misinterpret this last sentence. When you
Yeah, I misinterpreted it.
converted that sentence to an inequality, you got it backwards is all. And that kind of screwed up everything. When you make that mistake, you're not recovering from it, probably. Okay.
But I want to do more with those word-ish type problems because I'm not really the best at them because I do that where I forget.
No, I understand. I understand. No, it's not that easy to convert that sentence into an inequality. You just kind of have to try the inequality and see if it makes sense with the sentence. In other words, when you came up with when you came up with, hold on. Gosh, I hate that. That bar doesn't come up when I have my cursor. It only comes up when I use my mouse. When you came up with this as an answer, now try some numbers. See if they make sense. But y, in other words, according to this, y should be able to be 3, right?
Yeah.
Well, now read the sentence. Has to be at least 4 pass plays. Well, 3 doesn't qualify. That tells you that you got it backwards. In other words, it must be y is greater than or equal to 4. And now, what would satisfy that? Well, 5. And does 5 satisfy the word problem? Yes, it's 5 is at least 4. All right. Do you have any other word problems? We've still got a few minutes that we could do.
Well, I could do one from another homework that I got. From another sheet of homework.
What's that?
Yeah. Here, let me take a picture.
Yeah, send me something else that we can do for the last 10 minutes here.
Okay.
Wow.
Okay.
Hold on a second. I'm trying to figure out what the heck. My calendar stopped working all of a sudden. Huh. Let me reload it. Yeah, holler whenever you've sent it, and I'll check.
I sent it.
Okay. Let me just see where there it is. Registered that new. Okay. Let's have a look. All right. Good. So we don't need to worry about graphing it. You've defined your variables as x equals, hold on, let me read the thing.
Number times.
So x is the number of pinball machines. The number of pinball games played. And you don't always need to spell it out like that, but when you're just getting used to word problems, it helps to spell it out like that.
Uh-huh.
And this is the number of video games. All right, so let's read the words and see if we can translate it into inequality. He had enough quarters to play at most 20 times. What does that translate to?
X plus y is less than or equal to 20.
Yes. At most 20 means it has to be 20 or less. He wanted to play pinball at least 7 times. What does that translate?
X is greater than or equal to 7.
Greater than or equal to 7. And he wanted to play pinball at least 7 times and more than 6 video games. So
Y is greater than 6.
yeah, not greater than or equal, but greater than, because it says more than. At least,
Uh-huh.
at most, usually involve a less than and equal sign, whereas words like more than are strictly one way. That's either greater, well, that's greater than. Simple as that.
Uh-huh.
Okay? So, yeah, I think you got that. Just really, it's a question of interpreting the words at least or at most,
Uh-huh.
and more than or less than. If you can figure out what those 4 expressions mean, you're in business. All right, Logan, I'm going to let you run, and I will talk to you next Wednesday. Or, excuse me, next Tuesday, sorry. And my day's off.
Yeah.
I'm going